All right, in this video, we're going to pull up this itinerary here real quick. And so we went over cheat engine, signed, unsigned display in the last video. And in this one, we're going to talk about um, bits of a byte, or specifically the max value of data types. And it's kind of a misnomer because data types in general sort of abstract away. Um, there are specific data types like a double that have sort of a set size. So doubles, I want to say doubles are probably 64-bit. I don't know if that's are there cases where a double's not 64-bit? I'm sure there's some crazy, platform out there where it's not. But most data types don't have a specific range or size as far as bits and bytes go. Um, and some people say, oh well, an int's 4 bytes. Well, an int is 4 bytes when you're on a 32-bit platform. 64 bit platforms, I mean, this is getting into really low level stuff, some of which I'm not super clear on, and there's a reason for that. But because there's no need to really know it. Modern programming languages abstract a lot of that stuff away for you, and again, there's reasons for that. Productivity probably being foremost among them. But uh, to the point, most data types are architecture or platform dependent as far as their size. Um, in our case, we're talking about ints. So let's get into this in a little more detail. But this topic is inherently hard to explain and is fraught with difficulty because most people don't need to know this. But when you start getting into some of the more crazy things that cheat engine can do, then you're when you try to start doing certain things, you're essentially saying implicitly you're agreeing that I need to know these things, or I do know these things. Um, Otherwise, you're gonna just sort of be out in left field, and there's going to be problems and errors, and you're never going to be able to accomplish what you want to accomplish. And a fundamental reason for that, or one of them, there's many, but one of them is that you're not going to understand the different data types and their values, and a word versus a double word, and a nibble, and things like that. Um, and all of those phrases, you can if you want to right now, you can Google them, or look them up on Wikipedia. But basically, we're not going to deal with words and double words yet. We're just going to talk in terms of bits and bytes. And so, what do we mean by bits and bytes? Well, a popular vernacular that a lot of people hear is, well, oh, it's computers don't deal with values. They just, it's ones and zeros. Or this guy's so smart, he only just he sees ones and zeros. So, that's it's a popular thing in pop culture, and I dislike it. I think it's stupid. But I mean, as with all stupid things, I suppose there's kind of an essence of truth to it. So let's delve into um, what is a bit. Well, a bit is either a one or a zero, and I'm just going to type random crap up in this window here to sort of maybe provide some amount of video. Um, and so it's either a one or a zero. And there's a bit has no other value than that. Is you can string bits together in any way you want. You can have 6 million bits back to back, but the value of each bit is either going to be one or it's going to be a zero. Um, and so we're just going to say bit equals one or zero. That's it. That is the rule as when it comes to bits. So what's a byte? What is a byte? A byte is 8 bits. So 1, 2, 3, 4, 1, 2, 3, 4. We'll put a space in between them just to sort of make it a little visually clearer. So 1 byte has 8 values, and each value in that byte is either a one or a zero. Now, what does that mean for us? Well, what it means is when you want to know the value of a byte, what the computer is going to do is it's going to read these 8 bits, and then it's going to just return that bit pattern. So a byte has a bit pattern, and as far as the computer is concerned, that again, they're kind of glazing over a lot of the details here, but the general thing is the computer doesn't give a crap about what that bit pattern is, and it's designed that way. It's not supposed to give a crap, and it really does not. So an application says, give me the value of a byte. Computer says, fine. Returns a series of 8 bits, and then that's it. Hands off. Doesn't care. The application is free to do with that bit pattern whatever it wants. You can, as we were screwing around with earlier, you could, interpret that value as, 5, as -5, as, 100, as 0, as whatever you want. So that's sort of the basic premise of how values and memory locations, but we're going to call them values, how values are represented in memory. It's every data type that we're going to deal with Cheat Engine is the smallest unit that we can access. There's probably ways to access smaller units, but for our purposes, the smallest unit that you can access with Cheat Engine is 1 byte. So you're going to get 8 bits. And then if you want to talk about, a 2-byte integer, which, we'll pull up Cheat Engine here real quick. You can see that when you go to the value type that you want to scan, well, I want to scan, okay, apparently you can access binary. But anyway, we're not going to deal with that. You can access, there's a byte. So great. So we know that if we tell Cheat Engine we want to scan for a value type by byte, what Cheat Engine's going to do, is it's going to go through a memory, or the memory of an application, and it's going to scan for the bit pattern of whatever we enter in this text box is. So if we scan for 123, it's going to put the bit pattern of 123 into a byte, and then it's going to scan that memory, and it's just going to compare every byte. There's more subtlety to it, but basically it's just going to compare every byte that it finds to the bit pattern of whatever we entered in this text box. Text box is. Can I say text box? And then if it's a 2-byte integer, go up here, do 2 bytes. What it's going to do is it's basically going to take whatever we enter in that box, and it's going to put it into 2 bytes. But we're separating it like this. So we have 4 bits, a space, then 4 bits, then we, new line, 4 bits, and then 4 bits. We're doing that because we're a human, and we want sort of like visual demarcation, if you will. But as far as computers and memory and access and all that stuff is concerned, this is all, it's just one pattern. It's just a stream of bits. And when you enter something in this box and then you click first scan, it's literally just searching for a bit pattern that you enter. And we'll pick up more on this in the next video.